AI vision is moving so fast, it's almost hard to keep up. These models can look at an image and describe it with scary accuracy. But there's a huge catch. There's a fundamental limit to how they actually see the world. So, let's get into it. Think about it. Right now, most AI models are just kind of passive. They get an image, they look at it, process it, and spit out an answer. That's it. But what if they could be more active? What if an AI could actually interact with the image to figure things out?
Just look at this picture. If I asked you to read the phone number on that building, you wouldn't just glance at it from a distance, right? No way. You'd pinch and zoom on your phone, you'd squint, you'd try to get a closer look. What if an AI could do that? What if it could grab its own digital magnifying glass and really investigate? Well, that's exactly the problem a new model is trying to solve.
Okay, so this brings us right to what you could call AI's vision problem, because sometimes just looking isn't enough. For all their amazing power, these models get totally stumped by things that just need a second closer look.
And these images are just perfect examples. You've got rotated text on the left, super low contrast text on the right. Current AIs, as powerful as they are still passive. They can't just decide to rotate the image to read that sideways text or, crank up the contrast to make the faint words pop. These are the kinds of blind spots where they just fail on tasks a person would solve in a second just by fiddling with the image.
So if the problem is that the AI doesn't have the right tools, well, the solution is pretty obvious, right? You give it a toolkit. And that's where this gets really interesting. We're talking about giving the AI a digital Swiss Army knife for thinking.
And that brings us to Thyme. It's an acronym, stands for Think Beyond Images, which is just perfect, because this is a totally new way of doing things. Instead of just seeing an image, Thyme acts on it. And its digital Swiss Army knife? It's code. This model can actually write and run its own code to mess with images, do complex math, whatever it needs to do to find the answer. So the whole idea behind Thyme is built on 4 core principles. First, it needed a rich set of tools, the ability to crop, rotate, adjust contrast, and even do math. Second, and this is huge, it had to have high autonomy. It decides for itself when to use a tool and which one to grab. Then, of course, there's performance. The training had to be super efficient, and get this, it learned all these skills in just 200 GPU hours, which is honestly wild. And finally, the gains had to be stable, showing real, consistent improvement, not just a one-off trick.
Okay, so how does this all actually work under the hood? An AI that writes and runs its own code? How do you do that safely, and how do you make it effective?
Well, here's the basic pipeline. First, the model gets a question. It thinks about it for a second and decides, hey, can I answer this just by looking, or do I need a tool? If it needs a tool, it literally writes a little piece of Python code to do something specific. Then it sends that code over to a safe, secure place called a sandbox to actually run it. Let's break that down into 4 simple steps. Step 1, it analyzes the problem. It asks itself, do I need help here? If the answer is yes, it moves to step 2, generate Python code. It writes the exact code it needs, maybe to crop an image or run a calculation. Step 3, that code gets executed in the sandbox, a totally safe environment. And finally, step 4, it takes the result from the sandbox, say the zoomed-in image, and uses that new information to refine its final answer. Pretty cool, right? Now let's talk about this sandbox, because it is really the unsung hero of this whole system. Think of it as a secure little playground for the AI's code. Nothing dangerous can happen. But it's more than just a safety net. It actually helps the AI. It can automatically fix little syntax errors in the code, or handle tricky edge cases. So it basically lowers the bar for the AI to write successful code, making it a much more effective program.
The way they trained this thing is also super clever. They used what they call a split brain approach. See, when the AI is just thinking out loud, generating the text for its reasoning, they turn the temperature setting way up. That encourages it to be creative, to explore different ideas. But the moment it needs to write code, they crank the temperature way down. This makes it super focused and precise. It's a simple trick, but it's absolutely crucial. You get the best of both worlds, creative reasoning and rock-solid, reliable code.
All right, so that's all the theory. But the real question is, does it actually work in practice? Let's check out some examples and see this thing in action.
So remember this image from the beginning? The task is to read that tiny phone number. For a normal model, that's basically impossible. But Thyme looks at it, recognizes the problem, and on its own, it writes the code to crop the image and zoom right in on the sign. And just like that, it can easily read the number. Problem solved.
Or what about this one? The text is totally sideways. A normal AI would just throw up its hands. Not Thyme. It sees the problem, writes a quick line of code to rotate the image 90 degrees, and boom! The numbers are now perfectly readable. Simple.
Here's another great one. The word is so faint it's almost impossible to see. So what does Thyme do? It writes a little bit of code to jack up the contrast, and suddenly the word communities just pops right out. It turns what was an impossible reading task into a total cakewalk.
But it's not just about fixing images. Thyme's toolkit can also handle complex math. Take a look at this. The task here is to calculate the area of this shape after it's been scaled, using the coordinates in the diagram. This requires both seeing and reasoning. And this is how it solves it. Instead of trying to do all that geometry and multiplication inside its neural network, which is really prone to errors, Thyme is smart. It understands the math problem, and then it just offloads the actual number crunching. It writes the exact Python code to do the calculation and lets the code interpreter get the precise, correct answer. It's not just about having tools, it's about knowing when to use them.
Now, these individual examples are really cool, but the proof is in the data. Look at this chart. Across almost 20 different benchmarks, testing everything from perception to reasoning, Thyme is that orange line. And as you can see, it is consistently and significantly better than the baseline model without the tools. This proves it's not just a party trick. This is a real, robust improvement that works across the board.
So where does this leave us? What does this all mean for the future of AI? What's next for an AI that can actually act on its world?
Now, let's be real, this isn't magic. The tech still has its limits, and the researchers are upfront about them. For one, Thyme is only as smart as its underlying base model. If the base model can't understand the problem, it can't write the code. And yeah, the code it writes can still have bugs. Plus, we don't even have great benchmarks yet to really test how far we can push these kinds of abilities.
But I think this quote from the paper really nails the big picture here. This allows the model to treat the image not just as input, but as a dynamic entity that can be actively interrogated and transformed. That's the key. This is a fundamental shift. An image isn't just a static grid of pixels anymore. It's something the AI can poke, prod, and investigate to find the answers it's looking for.
And that really leaves us with the big question, doesn't it? We are watching AI make the leap from just passively observing the world to actively investigating it. So as these models get more powerful tools and more freedom to use them, what kind of incredible new possibilities are we about to unlock? And, of course, what new challenges will that bring? It's going to be fascinating to watch.